All right, today I'm going to look at this 12-volt marine light bulb, 12-volt DC obviously. I don't actually have an RV or a boat that I'd put this in, but it's kind of check it out how they made it. So let's throw some of the stuff up here. All right, let's see here. I've done a bulb by this company already. All right, seems to pop off pretty easily. Just a groove. So I got a bunch of LEDs, test points. All right, now let's have to hook this up to a power supply and see how it works. Okay, so I got this hooked up to my power supply to test out how many amps it's pulling. So move it off a little bit to the screen. Okay, and power on. Okay, so there I've got it set to 12 volts and it's showing that it's pulling showing 760 milliamps. Is that bright in the... Yeah, I mean, I don't really have this showing on here, but it doesn't really matter. Okay, so let's say this is plugged into an RV and the battery voltage is lower. As I bring the voltage down, we got 11 volts. It's pulling, or auto pulling, 850 milliamps. As we go down, 10 volts is pulling 1 amp. 9 volts is pulling 1.5 amps. Oops, a little too far. 8 is 1.65. 7 volts is 1.9. And then we start getting some shifts. Oh yeah, now I'm in the 6 range and it's up over 2 amps. Yeah, as I keep going down, we're in 5. Okay, now it shifts back to 1.8. And the lower and lower it goes, it's going back down. And let's see where it shuts off. We're at 2.5 volts and it's at 730 milliamps. And that looks like, no, it's still on. 1.7, okay, there it went off. So 1.5 volts, 280 milliamps, and it went off. So there's a point around 6 volts. If your battery is that low, it's pulling 2.2 amps. Ridiculous. It's going to drain your battery even faster. But looking in here, it looks like there are three segments inside each cob. There we go. It's gotten a little warm. Okay. So yeah, I got a little bit warm after that. I had a heck of a time getting this plate out of there. It was pretty well pushed in, and it's just full of potting compound, so that's going to be a heck of a thing to get out. Let's see if I can get closer on this at all. So there's 2 in series and 7 in parallel, and if there's 3 segments inside each cob, that's basically 6 LEDs in series, and around 3 volts a piece, that's 18 volts. So this, well, it's around 18 volts. But I was testing it off camera and it was showing that it was putting out 17 volts DC on these 2 pins. So each of these segments must be less than 3 volts forward voltage to add up to that. And okay, well, I'm just going to try to rip this apart. That is a lot. I was wondering why this was so heavy when I picked it up. And that's pretty solid. That might chip apart. All right. Okay. Came apart pretty easily. Down in here, there's a bunch of white pliable, it's not adhesive, so it must be some kind of just pliable potting compound. So they filled part of the bottom with that, hooked it up, crimped it, and then dumped the rest of the potting compound down into here. So this casing's similar to most casings, got a formed metal shell and then plastic coating that's made in a mold. Similar crimping, and it's got a black end, which is different, I think, than most sockets I've seen. I think they're white, but that's just cosmetic maybe, or maybe it's intentional. I don't know. All right. Okay, so got all the compound off of that. So let's take a look. Close look. FU, it says, not the fuse. It's not mad that I took the compound off. So we got 4 diodes instead of a bridge rectifier. Couple inductors, couple capacitors. They're all 25 volts. I think. 2 of them show that. I can't see on the 3rd one. Probably is though. Oops. This looks like 470. Another diodes, capacitors, resistors, and a chip. Let me see if I can even see what this is. Yeah, I'm going to have to look at that closer. I can't see what that is. Okay. So then for a comparison, got this light strip. You can buy these wherever. They come in whatever lengths. This particular one has 3 LEDs and a resistor in series. And then all of these segments are in parallel, running across the back for 12 volts. All right, well, here's the schematics. So this is the LED strip I was just looking at. 2 LEDs, a resistor, and then another LED. So just 150 ohm resistor. For the light bulb version, when I was looking at it originally, I thought, oh, there's a bridge rectifier in there, not even realizing it's DC. No idea why that's in there. Doesn't really make any sense. These capacitors in here are only rated for 25 volts. The boost converter chip is max input is 40 volts DC. So I'm pretty sure this would either just fail completely if you plug this, if you put this into a regular 120 volt AC or higher socket. It would either, something would, the fuse would probably blow, or the components would be damaged. So what's the point of this? And the only thing I could think of is if the wiring in your RV or boat or whatever you're putting this on is wired backwards, it would then allow the voltages to cause the thing to function, but that doesn't seem like the right thing to do. It's like it would function, but you really should, you know, plug it in, it doesn't work, realize that your wiring's wrong, and fix your wiring in your RV or boat. So that's, you know, the right polarity. So, you know, one diode, so that if you plug it in, it doesn't work. That didn't make any sense to me. But anyway, it does have a fuse. From what I could find, it's probably a 3 amp. I think it was a green P on there, I believe. Okay, then it has capacitors and inductors for stabilizing the voltage and current before it goes into this whole circuit. So pretty much everything over in this area is kind of how it's labeled when you look up the this MT7282 boost converter. It's pretty close. There's a couple extra things they added in here, but that's by design. So this whole thing is pretty much standard for how the data sheet shows. All right, where was I? Okay, so then the output, it goes to 2 in series, 7 in parallel LEDs, and I measured about 17 volts on there. So this is boosting from 12 to 17, and it's keeping it as constant as possibly can. Up here in the corner is where I was mapping out how much amps I was pulling at different voltages. So at 12 volts it was pulling 750 milliamps, and as you got higher up, you know, I went up to 16 volts, and it was, I think, 500 milliamps when it was at 16 volts. So, you know, if this bulb was in an RV and you're running the RV, so the alternator was running and charging, you know, the lead acid battery, it might be, you know, 15, 16 volts DC. And most, you know, properly run charged batteries are probably around 13 volts actually, instead of just straight 12. But as I started pulling the voltages down, or the voltage down to like simulate a low battery, the amps went up significantly. So once it got to 6 volts, it was pulling almost 2.5 amps. And then there was a switch over where it just basically went straight down linearly as the voltage went even lower, and just completely shut off at, I think it was like 1.5 volts. So this would, if the voltage was lower and this light was left on in a RV or boat or whatever, it would drain the battery like crazy. And one other random thing is on the outside of this, you know, where they stamp everything, and they have it labeled as 60 hertz. Like they changed, you know, 12 volts DC or 120 volts AC to 12 volts DC, but why did they leave 60 hertz on there? Doesn't make any sense. And what else? What else should I go over? Anything? Anything. What else? Okay, so the question is, if you were going to make a 12 volt light, would you make it this way? Or would you go the LED strip way if it's going to be used in an RV or a boat or something like that? I don't think this is the way I would go. You know, these seem quite simple. Yes, their intensity would vary based on what the voltage is and whatnot, but this seems overly complicated for just lighting. And then there's other things like, you know, some off-grid houses have 48 volt DC, you know, battery packs. Of course, they're converting those to run AC. but you could obviously use it to light something. So would you know, what kind of system would you use for that? Just thought this was interesting. So if you have any comments, leave them in the comments. I'll have all the stuff on here and the details below. All right, thanks for watching.